Hello friends, in this video we are going to cover what is a Kafka consumer group and what is rebalance. The problem Kafka consumer group solves. What exactly are those problems? So we'll cover the problems, the core benefits, the parallel processing logic, consumer group ID, rebalancing, partition assignment and failure handling. This rebalancing is the most interesting one. Think you have a Kafka topic, example Amazon order topic. It has got two partitions, partition 1 and partition 2. So the producer here, which is nothing but a Kafka client, keeps on producing messages to producers. Message number 1, message 2, message 3, and depending on the key of the messages arrive either in partition 1 or in partition 2. And think you have a Kafka consumer, which is just one consumer is attached to this topic, and it reads the messages and processes it. And the problem arises when there are a number of producers, they produce messages to the same Kafka topic. Think you have partition 1 and partition 2. It just indexed as 0 and 1. You can have another partition here and number of partitions depending on how the Kafka admin has configured your partitions. So think for now one Kafka topic and two partitions. When all these producers produce messages, the messages pile up in both the partitions. And what is the problem there? Think you have just one consumer who is reading from the topic. So in this case, because there are two partitions, the same consumer is reading from partition 1 as well as from partition 2. That is why the bottleneck happens. So it becomes slower. So this problem what Kafka consumer group solves is the client can create consumer group. Let's say this is a single consumer group, and in that group you can have multiple consumers, and each consumer is reading from one partition. In this case, you see, consumer 1 is reading from one partition, consumer 2 is reading from another partition. So that way they can process the messages parallelly, and the processing from this topic becomes faster because now there are two workers here. Okay, now so far we discussed the problem, the single consumer bottleneck, and the messages pile up when multiple producers keep on producing a lot of messages. And because there is one consumer, so there is always a single point of failure. Just think your Kubernetes pod is behaving or is configured as a single consumer, and due to resource constraints it stops processing messages or it dies. So your system fails there. It can no more process the messages. That is where the consumer group comes into picture. And what is the benefit? The benefit is parallel processing, increased throughput, and the load can be distributed because you have more than one consumer, and fault tolerance. Okay, now how the parallel processing happens. Multiple consumers, they can belong to the same group, like we saw here. Consumer 1 and consumer 2, they belong to the same group and they start consuming the messages, and they read from different partitions. Of course, as we saw, consumer 1 is reading from one partition, consumer 2 is reading from another partition. What is consumer limit versus total partitions? In a consumer group, you have consumer 1 and consumer 2. Each of the consumer will be assigned one partition each. There will never be a situation you have another consumer and it wants to read from one of the partitions because the partitions are already assigned. So the situation like this will never arise in Kafka. One partition and more than one consumer will never happen. But the other way is correct, where you have number of partitions assigned to a single consumer. That's fine. But this way, it will never happen. Okay. If you have same number of consumers as same number of partitions, each consumer will get one partition. That's it. Now let's look at consumer group ID. What are their functions and what are the naming strategies? So consumer group ID can be used as a team identifier. Number of consumers making a consumer group, they have a unique identifier. And if you're working across different teams, dev team, test team, you can have your unique consumer group ID as well. That is where it helps to progress and offset tracking. What does it mean? If you have another consumer group 2, this is 1. So Kafka broker remembers which consumer group has read from which offset. Okay, so it will track accordingly and it will give you that particular message from where you left. What is naming strategies? Every consumer group should have a unique and meaningful name. And if you are not bothered about exactly meaningful name, you can have a random name as well, but they should be unique. For example, if you are running a test suite, every time the test suite starts running, you can have a random consumer group ID. That's totally fine, but you have to make sure it is unique. And after you finish your test run, it's a best practice to delete that consumer group ID. Now let's look at rebalancing. This is very important aspect of Kafka. What exactly is rebalancing? When the rebalancing is triggered and what is the exact process is followed. So the rebalancing is triggered when a new consumer joins or a consumer leaves the existing consumer group or when the partition count changes. Let's look in a context. So now imagine you have 2 consumers and 2 partitions. So each of them is reading from a different partition. After some time, this consumer 2 leaves the group. What does it mean? It crashes or it dies. Okay. So because this particular consumer, let's say consumer 2, cannot send heartbeat to the Kafka broker anymore, so Kafka broker assumes that it has died. So it will immediately issue a rebalance. What does that mean? That this partition will be assigned to this consumer. This is how rebalancing works. Let's look at another scenario. You have 2 consumers and 3 partitions. Initially, consumer A is reading from here, consumer B is reading from the next partition. Because there is no more consumer, consumer B will be reading from the third partition as well. Now after certain time, a consumer joins this group. That means a new consumer is created and it is attached to the same group ID. What will happen? So Kafka will issue another rebalance. So this partition will be assigned to the new consumer. Now we have seen when new consumer joins, Kafka issues a rebalance. When a consumer leaves, Kafka issues a rebalance. When the partition count changes, also will Kafka issue a rebalance. That means now another partition gets created here. So Kafka will reassign the partitions to the existing consumers. Now let's look at what is the process followed by Kafka broker to achieve this rebalancing. So the moment things changes, one of the things happens from here. Kafka will pause the message consumption, redistribute the partition. Once that is done, it will resume the consumption. Okay. Now let's jump to the next topic, which is partition assignment. So Kafka does a fair distribution in partition assignment. Kafka makes sure one consumer per partition is assigned, and it prevents duplicate processing. Let's look at failure handling. What is missing heartbeat detection? Now if you remember, we had consumer 1 and consumer 2 here. So in Kafka ecosystem, at certain intervals, these consumers, they send heartbeat to the Kafka broker that I am alive. At any point of time, it stops sending. Kafka broker assumes that this particular consumer is not active, and it treats that consumer as left the group. Then it issues a rebalance. That is what heartbeat detection means. Then it does a automatic partition assignment, and it makes sure there is no message is unread. That's it. So what's next? Now we have covered what is a consumer group, and go to the channel and look for other videos where it covers producing and consuming, then poll, commit, partitions, offsets, retention period, and replication factor. All these concepts are very much required to work in the Kafka ecosystem. The most important bit is produce, consume, poll, and commit. Thanks for watching. Don't forget to like and subscribe.